Okay, this is how to answer projectile motion questions. The first step to answering any projectile motion question is to resolve the velocity. In most projectile motion questions, the projectile begins movement at an angle. If it isn't beginning at an angle, then you don't have to really resolve any velocities. It's just the velocity shown, and that's the horizontal velocity solely, or it's the vertical if the projectile's fired directly upwards. But in most, you're going to get at an angle. Now, the first step to solving these kinds of questions is to change the velocity of the projectile into two parts, the vertical and the horizontal. To do this, you use trigonometry as sine theta v equals the vertical component and cos theta v equals the horizontal component, as you basically turn this into a right-angled triangle with the horizontal down here and the vertical a line up here. After resolving the velocities, well, technically, you might not do this after resolving the velocities because it is best to just resolve one of the velocities first. It's best just to resolve the vertical velocity, as there are so many questions you can do without the horizontal velocity, but you basically can't do any without the vertical velocity. Although for some questions, the vertical velocity is basically zero because it's fired at an angle. It's not fired at an angle, rather, so yeah. For 18b, which is this question, we have to show that the time taken for the arrow to reach its maximum height is about 1.3 seconds. Now, the easiest way to tell if an arrow has reached its maximum height at a given point is if its velocity is 0. Because if it's 0, well, since it's accelerating downwards the whole time due to gravity, when its velocity is 0, that is the lowest. That's the lowest it's going to be while positive, of course. So it's not going to go any higher past that point. It's not going to go positive again past that point. So it's not going to go any higher than that point because it's effectively moved as high as it can before losing its velocity. But that's just for the vertical component. The horizontal component is completely unaffected by gravity. So we calculate our initial v for vertical, and that is equal to sine theta v, because sine times horizontal is equal to the opposite. So that gives us the initial vertical velocity. We can then use the Suvat equation, v equals ua plus t, which we rearrange to give v minus u over a equals t. If you're doing this in an exam and you're given a data sheet that includes all of the Suvat equations, I highly recommend that you look through all of them and you simply go through a list in your head. You tick off what you have, what you know, what you don't know, and what you need to know. For most projectile motions, you will assume that acceleration is equal to 9.81 meters per second squared, because that's the speed of free fall on Earth. In other questions, it might say it's something different, but if it's not explicitly said, it's in a non-normal Earth gravity environment. The speed of free fall is the speed that we would use, is the acceleration that we would use. And then we rearrange this equation to give us v minus, or the final velocity, which we want to be 0, minus u, which is that initial velocity, equals the time. So we get the time taken for it to get to 0 vertical velocity. So for this, we have it as 0. For the final velocity, for the initial velocity, we simply put in sine 1168, and then we have to make sure that we put the acceleration as negative, because the initial velocity is acting upward and the acceleration is acting downward in the opposite direction. So you have to make note of that, either by putting the acceleration as negative or by putting the initial velocity as negative. Otherwise, you'll get a negative time. Obviously, if you do get a negative time, or if you're doing some other kind of question, like a distance question, and that turns out negative, you know that you've probably gone wrong somewhere. If everything else looks fine, it might just be signs, and you can just flip the sign of your answer to positive. I'd advise having another look at your equation, don't get me wrong, but you can always flip it back to positive. It's worth putting answers to these kinds, and what I mean by these kinds is the show that questions, to one more significant figure than the question gives you. So here it says 1.3, I would put down 1.32. Of course, you'd write down all your working for these questions as well, but writing down the exact answer that you got to an extra significant figure shows that you really did the calculations and you really know what you're talking about. In the mark scheme, it'll typically show the examiner what an additional significant figure would look like on top of this. For a different kind of projectile motion question, calculating the total distance travelled, we would need the horizontal component. Apart from finding the horizontal component, it's even easier to do these kinds of questions, since we now know the time when the arrow has 0 vertical velocity. This is a bit of a neat trick, but since the acceleration is constant the whole time, if you know the time when the arrow has 0v, you also know the time it'll take for the arrow to go back to where it started, because that's literally just double the time taken for it to get to 0v. So t in this case is 2.64. Now the rest of this is just simple speed times time equals distance traveled. So, I mean, yeah, we just need to find the horizontal component, which we know is equal to cos theta t as cos times an angle. Cos of an angle times the hypotenuse will give you the adjacent line to that angle. And that will tell us the distance horizontally travelled from where the arrow was first fired. For this question, that means cos 11, 68 speed times the time we mentioned earlier equals dh. So the distance horizontal is 176.2. In this question, it asked us to calculate the distance by which the arrow misses the target. Since the target is 90 meters away from the bow, we can simply subtract 90 from this to give us the answer of 86. Thank you very much for watching. These questions, to be honest, are a matter of practice and a matter of going through the SUVAT equations you're given, going through the information you know, and figuring out what it is you're missing, and then using your toolbox of equations, most of which will just be given to you, and a bit of logic to work out how you're going to get from what you have to what you need. Good luck at your exams. This is probably going to be the last video I make covering A-level content for Physics Paper 1. I will do other physics papers, and I will do other chemistry papers, and I will do biology papers, possibly. But for now, this is the last paper I'll make, as my exam is not quite tomorrow, but the day after. So good luck, everyone, and I hope you enjoy your exams.